All right, so we are starting the second part of Unit 7, and today I'm just going to be defining for you a few things. I'm going to define for you what does it mean to put an angle in standard position, what are coterminal angles, and what is a reference angle. Okay, we used a variable. Did anybody remember what variable we used for trigonometry? It's a Greek letter. It looks like this. Do you remember the name of that Greek letter? Not omega, it's theta. Okay, and it's just a letter from the Greek alphabet. And up until this point, most of the letters we use for variables are from our alphabet, and X tends to be the variable of choice, or the letter of choice, right? Solve for X, solve for X. Sometimes we use other letters. Now, when solving for angles, theta tends to take that place. Solve for theta. And just know that it's not a zero, okay? It's a letter from another alphabet that we're not used to seeing. Sometimes we'll use letters from our alphabet. I'll say solve for sine of X or solve for sine of Y, but often you'll see that, okay? All right, so let's take a look at, if I have theta is 30 degrees, and I want to graph that angle in the XY coordinate system, where would I put that? Okay, so I'm going to draw our X and Y axes here. And your X-axis, the positive X-axis, is where 0 degrees will always be. Okay. That's kind of your starting point. And when we're looking at a positive angle, we move around in a counterclockwise direction. Okay, so this pointing north would be 90 degrees. And you see that, okay, 30 degrees is going to rest somewhere between 0 and 90 degrees, closer to 0 degrees. So 30 degrees somewhere around here. Okay, and this angle here that touches the x-axis goes from 0 up to our terminal side here, pointed at 30 degrees. And so that would be the standard position of 30 degrees. If we had theta is 120 degrees. So again, start at locating 0 degrees. We're going to move counterclockwise around the in a circle format around these x and y axes. Here's 90 degrees, so we still need to go further. Keep going. Another 90 would be at 180. And 120 is going to be between 90 and 180. What quadrant is that? This is quadrant 2, okay? Quadrant just means corner, and often when we talk about quadrants, we use Roman numerals. So this is quadrant 1, quadrant 2, quadrant 3 would be here. Quadrant 4 would be bottom right, okay? So we're going to end up in quadrant 2. And is 120 closer to 90 or closer to 180? A little closer to 90, so pointed about right here. And you don't have to be exact. What's important is that you're in the correct quadrant. That's my 120 degrees. And again, the angle goes from my terminal side to my starting point at 0 degrees. Okay, and that's my 120 degrees in standard form. What if we have something like this? Theta is 500 degrees. Okay. Well, here's 0. Still positive, so we're moving counterclockwise. Here's 90. We've got a ways to go to get close to 500. So if I work my way around here, that's 180, 270. And then what's going to happen? You get 360. And notice that 0 degrees and 360 degrees are at the same exact location. And we'll have to have that. And we can spin around this as many times as we want, but as you spin around it twice, you know, or a third time or fourth time, it's going to have to share a location with another number. Okay, and so 360, we're getting closer to 500. If I add another 90 to that, I'm at 450. So 450 degrees and 90 degrees are at the same location. If I go another 90, I'm at 540. So 540 and 180 are at the same location. And 500 is between 450 and 540, a little closer to 540. So 500 would be right here. Can anybody think of another angle that would share that same location with 500? Yeah, 140. Yeah, how do you know? Okay, so 500 is 40 from 540. And so if we're at 180 and we go back 40, we're at 140. So 500 and even 140 would be at the same location. Okay, but that's graphing that in standard position. And you can go around a third time and a fourth time. You can also have a negative angle. Yeah, question? Well, if we were to draw the angle, it looks something like this. Right? Which shows I've gone around once and a little bit more. Yeah, go ahead and do that. We can have negative angles as well. If I have theta equals negative 225. So the negative indicates which direction we're going to go around. So we still would start at 0 degrees, which is our starting point. But because it's a negative angle, we're going to go clockwise instead of counterclockwise. So this would be negative 90 degrees. This would be negative 180 degrees. Just keep adding negative 90. This would be negative 270 degrees. And so negative 225 would be somewhere between negative 180 and negative 270. Which one's it closer to? It's actually right in between. It's 45 degrees from each of them. Okay. Anybody give me a positive angle that would be shared with negative 225? Not 140. 135, yeah. Because if we look at this distance here, this is 45 degrees, and we know that this is also positive 180. It's negative 180 and positive 180. And if I go back 45 from positive 180, I get to 135. So these angles that share the same location are what we call coterminal angles. Co meaning we share, terminal meaning that's where we end up. And so that's going to be the next thing we're going to define for you. What are coterminal angles? And let's start with 30 degrees here. So 30 degrees, there are other angles out there that have that same direction or share that same, think of this as a spinner that spins around. There's, that didn't even spin around once, right? But I could spin around once and end up there as well. What other angles would share that same location? So if we start at 30 and we spin a full circle, so I add 360 to that, right? So I'm here and I go all the way around once. That's going to be 390 degrees. So 30 and 390 degrees are coterminal. They share the same spot. We could also say, well, what if we start at 30 and we spin around once and we spin around one more time, right? And we're still going to be at the same location. What would that add up to? So 750 is another option. And then we can continue that. We can add 363 times or 4 times and so on. We can also go the other direction. Instead of adding, we could start at 30 and subtract 360, which just means that we're spinning it the other direction. And so 30 minus 360 would be negative 330. Right? Or we could spin it a few times that direction. So all these share the same location, and so we call them all coterminal angles. I'm going to give one more example of this. Let's say 200 degrees. Okay. Come up with at least 4 other angles that are coterminal with 200 degrees. At least some positive, some negative. Okay. Come up with 4 more angles that are coterminal with 200 degrees. Alexis, did you get one more? 560. What did you do to get it? Good. So 200 plus 360 is 560. So that's one more. And those are coterminal because they're pointing at the same direction. Suzuki, do you have a different one? Okay. How'd you get that one? Okay. So if I started with 200, you added 360 twice, huh? And that came out to 1,120. Good. All right. Let's go for a negative coterminal angle. Cody, do you have a negative one? So how'd you get that one? 200 minus 360, and you got what again? So 360 minus 200 would be just 160? Yeah. Negative 160. We got it. All right. And who's got one more? Yeah, Luis. And so you did 200 minus 360 minus 360? And you got negative what? 5. Okay. So all these angles have something in common. They all are, if I asked you to graph any of them, they would all give you the same picture. Yeah. Okay, 920. That 11 becomes a thick 9 there, right? There we go. 920. Okay. And so again, these are what we call coterminal angles. Okay. So just understanding some of that vocab. Last thing I want to go over with you is what is a reference angle. So we've talked about standard position, how to graph something in standard position, how to find coterminal angles, add or subtract 360 as many times as you like, right? And last thing is a reference angle. So a reference angle, so when we talk about an angle, here's an angle right here for us. Every angle has a vertex, right? And a reference angle has a vertex at 0, 0. So this is one key thing. So vertex is at 0, 0. Second thing, this reference angle always is positive. There are negative angles out there, but a reference angle will always be positive. It's an acute angle. Right? And it's formed by the terminal side and always the x-axis, never the y-axis. I'll go over that with you. And the terminal side is what we've been graphing, like up here. When we graph in standard position, this is the terminal side here, right? Or wherever you end up, that's our terminal side. And that's where we get the word coterminal, right? So wherever you're pointed after you plot that angle would be your terminal side. So a reference angle has a vertex at 0, 0. It's always positive. It's an acute angle formed by the terminal side and the x-axis. So let's take a look here. So let's say I give you an angle of 240 degrees and ask you to find the reference angle that goes along with this angle. Well, you start by plotting this in standard position. So here's 0 degrees, moving counterclockwise. Here's 90, 180, 270, just counting by 90 degrees each time. And 240 is going to be between 180 and 270, a little closer to 270. So this is my terminal side that I'm drawing here and pointed at 240. And so it says, okay, my reference angle has a vertex at 0, 0, so I'm putting that little point there. Here's my terminal side. Here's my x-axis. So it's the reference angle is just that little angle right there. Okay. And typically what we're going to be doing and getting the practice of this is we're going to draw a reference triangle. It's going to be this right triangle here. Okay. And that's where we're going to get to the trig part. So what's our reference angle here going to be? What is that angle right in there that I 60, because the terminal side's pointed at 240, right? The x-axis is pointed at 180, and so you subtract, what's the difference between them? You go 240 minus 180, and you get your 60 degrees. So what kind of triangle is that? got your 30, 60, 90, right? Those are going to come back, and we're going to have to remember some stuff about that. Not yet, but we're headed that way. And you can kind of see where triangles are coming up here and where trig is going to be introduced. So 240 has a reference angle of 60 degrees. Now, the variable that we use for a reference angle is theta. We can't use theta because theta is 240. So we put theta with a little prime. So this little piece here we call, so this is theta prime is 60 degrees. And again, I'll write out what I said. So theta prime. Okay. So that's the reference angle for 240 degrees. So, and we have our reference triangle, which is a 30, 60, 90, and we know stuff about that, and we'd be able to work with that. So I'm going to give you another angle. I want you to try to find the reference angle of that angle. So let's do theta equals negative 315 degrees. Find the reference angle of negative 315 degrees. Draw a picture like we did. Work through that. So what quadrant are we going to end up in? What quadrant is negative 315 degrees located in? Quadrant 1. Okay, that's good. So that's the first kind of thing, to locate negative 315 degrees. So if it's a negative angle, so I start at 0 and go the negative direction. This is negative 180, so keep going. This is negative 270. Keep going. Negative 360 is coterminal with 0 degrees, right? They share the same spot. And so negative 315 is right in between those two. Okay, so I plotted it in standard position. Now I want my reference angle. And my reference angle uses this side, this is our terminal side, with the x-axis, not the y-axis. So I'm going to draw my reference triangle, which is a right triangle here. And a triangle has 3 angles in it, but only one of those angles is your reference angle, and it's the angle that has the 0, 0 as its vertex. So it's always this one right here. Okay. So what's it going to be? So I heard 45 and I heard negative 45. But remember, always positive. Reference angle is always positive. So even when you subtract, if you get a negative, like say you go negative 360 minus a negative 270, you get negative 45, make it positive at the end. So this is going to be 45 degrees. Okay. So theta prime, or reference angle, 45 degrees. Okay. That's all I want to show you for the notes. I want to take a quick look at the homework here. Homework is going to be page 1 and page 2. On number 1 through 6, all you have to do is draw the angle in standard position. On numbers 7 through 12, you just need to say what quadrant that angle's in. Quadrant 1, 2, 3, or 4. When you get to 13 through 18, you got to find coterminal angles, 2 of them. One of them has to be positive, one of them has to be negative. And then on page 2, this is where you're going to do what we were just doing. We're going to You're going to draw the angle in standard position. You're going to draw the right triangle using the terminal side of the angle and the x-axis. And then you're going to show what the reference angle is in your diagram and find the measure of your reference angle. And so that's what your homework is, and I'm going to let you work on it now.